All right, so in this section, we're going to be talking about linear inequalities. And what we're going to be doing is we'll do the 3 steps. We're going to solve, we will graph, and we will write the interval notation. Now, in order for us to do 2 out of these 3 things, in other words, in order for us to do the graphing and the interval notation, let's go ahead, let's review what our inequality symbols are. So inequality symbols, or inequalities, will look like this. And remember, we read them left to right. So these are read left to right. So less than, greater than, less than or equal to, greater than or equal to. And when you're graphing them, the symbols that we will be using will be either parentheses for the less than or greater than, and then brackets for the greater than or equal to and less than or equal to. And one more thing, when we graph on our number line, if you happen to graph this far left arrow, we call that negative infinity. And if you happen to graph this far right arrow, we're going to call that positive infinity. And when we use negative or positive infinity in terms of interval notation, you will always use parentheses when you're writing out the interval notation. Okay? So the best course of action here is just to go ahead and just start doing some examples. So we're going to do a couple. Keep things nice and light. So the first one, we're just going to follow those directions earlier, which are solve, graph, write the interval notation. I'm just writing out the directions real quick. Here we go. And what we're going to be doing here is we're going to solve the very first one. So we'll call this part A. X plus 4 is greater than or equal to 7. Okay? So for this, you're just going to subtract 4 from both sides. That gives us X is greater than 3. And from here, we can go ahead and we can graph. So off to the right here, I'm going to graph. Now, real quick, just so we're aware, this inequality symbol, it's greater than, okay, or equal to, but more importantly, the greater than, that looks like this arrow on the far right side. So what we're going to be doing is we are going to use, sorry, give me 1 second. There we go. We're going to be using a bracket because it's greater than or equal to. And we're going to shade the right-hand side. Now, once you graph, the interval notation will be looking at you. Remember, start with your lowest value, which is going to be 3. Then our highest value, in this case, we shaded that far right arrow, so it's going to be positive infinity. The 3 will get a bracket because that's what we used on the number line. And infinities always get parentheses. Okay? So let's go ahead. Let's do the next one, part B. So with this one, we need to be a little bit careful. Now, we already have the directions. And the reason for that is with this example here, okay, we're going to have to divide both sides by -7. Okay, now here's the issue. When we divide or multiply by a negative number, so I'm going to write this row off to the right-hand side. Oops, sorry, my alarm just went off. You probably heard that. So if we multiply or divide by a negative number, then we must, and this is huge, we must reverse the inequality symbol. Okay? Now, the reason for this, okay, the reason for this is if you look on the right-hand side, we have -70 divided by -7. Our sign of the number actually changes. And because of that change, we have to reverse the order. So we get R, we get 10, and then in the middle, we get greater than or equal to, which is our sign reversed. So now we can just go ahead underneath, Let's go ahead and graph. 10 is going to be on the right-hand side of 0. I'm going to shade to the right. And I'm going to use a bracket because I have less than, or I'm sorry, I have greater than or equal to. And then my interval notation will be bracket 10, comma, infinity. Okay? Now, the only way that I can make some of these problems more difficult is just by giving you a more complicated situation. For example, 9y plus 2 times a quantity of y plus 6 is greater than 5y minus 24. So notice it's the same. It's basically the same exact type of problem. It's just there are more things or there's more stuff going on in this situation. So what we're going to have to do first is distribute the 2. So that's going to give me 2y plus 16 is greater than or equal to 5y minus 24. Then I need to group like terms. So 9 plus 2 is 11y plus 16, which is greater than 5y minus 24. Now we're going to get variable terms on one side, constant terms on the opposite side. So I will subtract 5y because I want to get the y's together first. So that gives me 6y plus 16, which is greater than negative 24. The next thing I'm going to do is I'm going to go ahead and subtract 16 from both sides. All right. So that's going to give me y is greater than. Now, excuse me, remember, signs are the same, so you add the numbers, keep the sign. So we get we get 6y is greater than 40. And then finally, we will divide both sides by 6 to give me y is greater than 40 over 6. Now, to simplify this, an easy way to do this is just to go ahead and write out the prime factorizations of 40 and 6 respectively. So 40 is 2 times 2 times 2 times 5. That's how I got that. All I did was just break it down. I'm going to write 40. Actually, you know what I'm going to do? I'm going to write this. 2 times 2 times 2 times 5. There's 40. 6 is just 2 times 3. So as you can see here, the only thing that reduces is one set of 2. Everything else will be in our final answer. So 2 times 2 is 4. Times 5 is 20 over 3. Okay, and there's our solution. Now we're going to go ahead and graph this. 20 over 3 is a positive number, so it's going to be to the right of 0. And we're going to be using a parenthesis this time. And we're going to shade to the right because we want values of y that are just greater than 20 over 3. And finally, our starting value for our interval is 20 over 3. Our ending value is going to be infinity. And since we use the parenthesis on the number line, we will use a parenthesis with our interval notation. Okay? Now, there's going to be a time where we come up with these, what I like to call a special case. So these next two examples will be special cases. And all they really do is require you to think about what's happening, okay? So, same directions, all right? 4b minus 3 is greater than 3 minus b. I'm sorry, I said that backwards. 4b minus 3 times a quantity, 3 minus b, is greater than 5 times b minus 6 plus 2b. Okay? So we're gonna approach this problem just like everything else. I need to distribute, so I get negative 9 plus 3b, which is greater than 5b minus 30 plus 2b. Now I'll group like terms on the left, group like terms on the right. 4 plus 3b is going to be 7b minus 9, which is greater than 5b plus 2b is going to be 7b minus 30. Now I will get variable terms on one side, constant terms on the opposite side. So I'm going to get my variable terms together first. So I will subtract 7b from both sides. And notice I've run into this situation here where my variables basically canceled out. So my variable terms canceled out. Oops, running out of space. So my variable terms canceled out. And now I need to look at this and make a decision. Okay, and this is what I mean by a special case. So when you think about this, if you were to graph -7 and -30 on a number line, notice that -7 is to the right of -30. Also, we have to remember that the further you move to the right, the larger the values get. The further you move to the left, the smaller the values get. So if I'm comparing -7 and -30, this is a true statement. And what this means is no matter what value of B I choose, we will always get a true statement. Always. Okay? So, like I said, if you think about it, if you take B equals 1, okay, and you substitute it in, the left side will always be greater than the right side. No matter what you do, that will always be the case. And the reason for that is right here. Because no matter what, the variables are always going to cancel themselves out. Always. So no matter what you do, you are always going to be left over with this situation, -7, which is greater than -30. And that's a true statement. So what we need to do now is just say, okay, well, we have a true statement, but what does that look like when we graph? Well, if you think about it, no matter what value of B you choose, you will always get a true statement, which means you could pick values on the right of 0. So I can shade to the right. I can also shade to the left. In other words, you shade the entire number line, which means the interval notation, although it may seem complicated, is actually very simple. You've shaded that arrow on the left, and we know that's -infinity. You shaded this arrow on the right, and you know that's +infinity, and you've shaded everything in between. So our interval notation is going to be -infinity to +infinity. All right? Now, the last problem that I want us to look at is another special case. All right? So we're going to go ahead and do this one. So we're going to do 1/3 A minus 1/8 A, which is greater than 5/24 A plus 3/4. Okay? So first things first, I see denominators all over the place. Therefore, I'm going to try to find my LCD. The easiest way to do that is to write all the denominators in numerical order. All right. And let's go ahead and let's prime factorize each of them. 3 is just 3. Now notice the space I left there. And the only reason why I left that space is because I know where this is going. So please make sure you put a space there. 4 is really 2 times 2. 8 is 2 times 2 times 2. And then 24. Well, 24, we're going to have to break down a little bit. So that's going to be 8 and 3. And then we know 8 is 2 times 2 times 2. So 24 is 2 times 2 times 2 times 3. Now, my LCD will be straight down the column. So 2 times 2 times 2 times 3. So my LCD here is going to be 24. Okay? So let's go ahead and let's multiply every single value here, or every single term, by 24. So 24 times 1/3 A minus 24 times 1/8 a, which is greater than 24 times 5 over 24a, plus 24 times 3 over 4. All right. Now, we're going to simplify all of our denominators from left to right. 24 divided by 3 is going to be 8 times 1a. 24 divided by 8 is 3 times 1a, which is greater than. 24 divided by 24 is 1, so you're left over with 5a. And then 24 divided by 4 is 6 times 3. So let's go ahead, let's clean this up. We got 8a minus 3a, which is greater than 5a plus 18. Now, 8a minus 3a, we can combine them to give us 5a, which is greater than 5a plus 18. And then finally, we're going to get our variable terms together by subtracting 5a from both sides. And the same exact situation in the previous problem happened here. Notice our variables canceled out. However, we need to make a decision again. Here is the decision we need to make. We need to ask ourselves, is 0 greater than 18? Well, the answer to that is no. This is false. So, there is no solution to this problem. I was going to write the words to this problem. We don't have to do that. There is no solution to this, which means there's no graph and there's no interval notation. So, I hope this helps and I hope this clarifies some of the things we've been doing in class, okay? And I will see you in the next video. Later.